everyone. So we are continuing with the chapter of Introduction to Trigonometry, and we have already finished first 4 questions of exercise 8.4 in our previous videos, and now the last question of the last exercise of this chapter, question number 5. It says, prove the following identities where the angles involved are acute angles for which the expressions are defined. So first one is cosec theta minus cot theta whole square is equal to 1 minus cos theta divided by 1 plus cos theta. So now we are going to work on the left hand side. We have cosec theta, which can be written as 1 by sin theta, minus cot can be written as cos theta by sin theta whole square. Now if I take the LCM, I get 1 minus cos theta divided by sin theta and whole square. So 1 minus cos theta whole square divided by sin square theta. Now 1 minus cos theta whole square and sin square theta can be written as 1 minus cos square theta. Now this can be written as 1 minus cos theta into 1 minus cos theta, and in the denominator I can use the identity a square minus b square, which will be equal to a plus b into a minus b. So we have 1 plus cos theta multiplied by 1 minus cos theta, and this gets cancelled. So I get 1 minus cos theta by 1 plus cos theta, and this is equal to right hand side, hence proved. The second part is cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A is equal to 2 sec A. So we are going to work on the left hand side, and I'll take the LCM. LCM is cos A into 1 plus sin A. Here we get cos square A plus 1 plus sin A whole square. Now cos square A I can write down as 1 minus sin square A plus 1 plus sin A whole square divided by cos A into 1 plus sin A. 1 minus sin square A is equal to 1 plus sin A into 1 minus sin A plus 1 plus sin A whole square divided by cos A into 1 plus sin A. Now I can take 1 plus sin A common from both the terms, and I will be left with 1 minus sin A plus 1 plus sin A. And in the denominator I have cos A into 1 plus sin A. Now 1 plus sin A gets cancelled with 1 plus sin A, and minus sin A with plus sin A. I get 2 by cos A, and cos A can be written as sec A. So twice sec A, which is equal to the right hand side. So hence proved. Now the third part, it says tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta is equal to 1 plus sec theta into cosec theta. So now let's convert everything into sin theta and cos theta. So tan theta will be equal to sin. Again here also we are working on the left hand side. So tan theta is sin theta divided by cos theta, and this is 1 minus cos theta by sin theta. plus cot theta can be written as cos theta by sin theta divided by now 1 minus tan theta is sin theta by cos theta. Now this would be equal to sin theta divided by cos theta, sin theta minus cos theta, as I have taken the LCM as sin theta. Now plus cos theta by sin theta, and in the denominator I have cos theta minus sin theta divided by cos theta. Now this can be written as sin theta into sin theta divided by cos theta into sin theta minus cos theta, plus here we have cos theta multiplied by cos theta divided by sin theta into cos theta minus sin theta. This would be sin square theta by cos theta into sin theta minus cos theta. Now because I want sin theta minus cos theta here, so I'll take the negative sign outside and this becomes cos square theta, and in the denominator I'll have sin theta into now sin theta minus cos theta. So we took the negative sign common or minus 1 common from the denominator. Now we'll take the LCM. LCM will be sin theta cos theta into sin theta minus cos theta. Here I have sin cube theta minus cos cube theta. Now I have to use the identity a cube minus b cube, which is equal to a minus b. So we have sin theta minus cos theta multiplied by a square, so sin square theta plus ab, so sin theta cos theta and plus b square, so that will be cos square theta divided by sin theta cos theta multiplied by sin theta minus cos theta. Now sin theta minus cos theta gets cancelled with sin theta minus cos theta in the denominator, and also sin square theta plus cos square theta will be 1 plus sin theta cos theta divided by sin theta cos theta. Now I can write down this as 1 by sin theta cos theta plus sin theta cos theta divided by sin theta cos theta. This and this gets cancelled, and 1 by sin theta cos theta I can write down as sec theta into cosec theta plus 1. So this is equal to right hand side, hence proved. Let's move to the fourth part, which says 1 plus sec a by sec a is equal to sin square a divided by 1 minus cos a. Here I think we are going to solve left hand side and right hand side simultaneously. 1 plus 1 by cos a. Sec a is inverse of cos, and this is also 1 by cos a. Taking the LCM, I'll get cos a plus 1 divided by cos a, and inverse of 1 by cos a will become cos a. They get cancelled, so I get cos a plus 1. And let's see on the right hand side, sin square a can be written as 1 minus cos square a, and in the denominator we have 1 minus cos a. Now we know the identity 1 minus cos a into 1 plus cos a that is 1 minus cos square a divided by 1 minus cos a. 1 minus cos a gets cancelled with 1 minus cos a, so we get 1 plus cos a. So both are equal. Left hand side is equal to right hand side. Hence proved. Now the fifth part is cos a minus sin a plus 1 divided by cos a plus sin a minus 1 is equal to cosec a plus cot a. We can do in different ways, but here it has been mentioned that we have to use the identity cosec square a is equal to 1 plus cot square a. Let's start doing left hand side, and to convert into cosec and cot, let's divide both numerator and denominator by sin a. So cos a by sin a will give me cot a minus 1 plus 1 by sin a will be equal to cosec a divided by, now in the denominator also we need to divide each term by sin a. So again cos a by sin a will give me cot a, then this would be plus 1 and minus cosec a. Now this would be equal to, here I can write down to dividing both numerator and denominator by sin a. Now this is equal to cot a minus sin I can take common, and I can write down 1 minus cosec a divided by cot a plus 1 minus cosec a. Now we can do like we rationalize the denominator, so I can multiply the numerator by cot a minus 1 minus cosec a, and the denominator too we can do cot a plus 1 minus cosec a multiplied by cot a minus 1 minus cosec a. Now in the numerator we have like a minus b whole square, so I can do a square, so cot square a plus b square 1 minus cosec a whole square minus 2ab, so 2 cot a into 1 minus cosec a divided by, in the denominator we have a plus b into a minus b, so that will be a square, so cot square a minus b square, so 1 minus cosec a whole square. Now I can open the brackets for this, so I have cot square a plus 1 plus cosec square a minus 2 cosec a minus 2 cot a and plus 2 cot a cosec a divided by cot square a minus 1 plus cosec square a minus 2 cosec a. Now I can write down cot square a as cosec square a minus 1, then we have plus 1 here plus cosec square a minus 2 cosec a minus 2 cot a plus 2 cot a cosec a divided by, again here also cot square a can be written as cosec square a minus 1, and I'll open the bracket, so minus 1 minus cosec square A plus 2 cosec A. Now here minus 1 plus 1 gets cancelled and I get 2 cosec square A minus 2 cosec A minus 2 cot A plus 2 cot A cosec A divided by cosec square A, and cosec square A gets cancelled and I can write down here as twice cosec A minus 2. Now in the numerator I have 4 terms and I can take 2 cosec A common in the first 2 terms and I have cosec A minus 1. In the next 2 terms also I can take plus 2 cot A common, I get cosec A minus 1. In the denominator I can take 2 common, so I have cosec A minus 1. Now in the numerator in both the terms I can take 2 common and I can write down as cosec A minus 1, and we are left with cosec A plus cot A divided by 2 cosec A minus 1. 2 gets cancelled and cosec A minus 1, cosec A minus 1 gets cancelled. So we get cosec A plus cot A. This is equal to right hand side, so hence proved. Now the sixth part, it is the square root of 1 plus sin A divided by 1 minus sin A is equal to sec A plus tan A. So now in this we are going to solve the left hand side. We have square root. Let's divide both the numerator and denominator by 1 plus sin A. So numerator will become 1 plus sin A into 1 plus sin A, and in the denominator we have 1 minus sin A into 1 plus sin A. 1 plus sin A whole square, and in the denominator we have 1 minus sin square A. So A plus B into A minus B is A square minus B square. Now in the numerator we have 1 plus sin A whole square, and in denominator instead of 1 minus sin square A I can write down as cos square A. Now I can remove the square root sign, so I'll have 1 plus sin A divided by cos A. Now let's write down this as 1 by cos A plus sin A by cos A. Now 1 by cos A is equal to sec A, and sin A by cos A is equal to tan A. This is equal to right hand side, hence proved. Seventh part, which is sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta and equal to tan theta. So now we are going to work on our left hand side. So I can take sin theta common and I'll get 1 minus 2 sin square theta divided by, so here in denominator I can take cos theta common, so I will have 2 cos square theta minus 1. Now this is equal to sin theta, and this is 1 minus 2, and sin square theta I can write down as 1 minus cos square theta divided by cos theta and 2 cos square theta minus 1. Now this is equal to sine theta, and I'll open the bracket, so I'll have 1 minus 2 plus 2 cos square theta, and in the denominator we have cos theta, 2 cos square theta minus 1. This is equal to sine theta into 2 cos square theta minus 1 divided by cos theta into 2 cos square theta minus 1. This and this gets cancelled, so we are left with sine theta divided by cos theta, that is equal to tan theta. So this is equal to right hand side, so hence proved. Now let's move to the 8th part. It says sin a plus cosec a whole square plus cos a plus sec a whole square is equal to 7 plus tan square a plus cot square a. So let's again work on the left hand side. Now sin a plus cosec a whole square, so a plus b whole square. So I can write down this as sin square a plus cosec square a plus twice sin a cosec a, and for the second term plus cos square a plus sec square a plus twice cos a sec a. Now this here we have sin square a plus cos square a, that will be equal to 1, and I can write down cosec square a and plus sec square a. Now 2 sin a and cosec a will become 2, so I can write down this as twice sin a divided by cosec is 1 by sin, and plus 2 into cos a by cos a. So this and this gets cancelled, this and this gets cancelled. Here we have 1, and cosec square a I can write down as cot square a plus 1, and sec square I can write down as 1 plus tan square a plus 2 plus 2. So now we have 7 plus tan square a plus cot square a. This is equal to right hand side, hence proved. Now the 9th part, which says cosec a minus sin a multiplied by sec a minus cos a is equal to 1 by tan a plus cot a. So let's start solving left hand side, and we need to multiply a binomial by binomial. So now cosec a into sec a minus cos a cosec a minus sin a into sec a and plus sin a cos a. Now we can change everything into sin and cos. So cosec a and sec a will be 1 by sin a cos a and minus cos a divided by sin a. Cosec a is inverse of sin, minus sin a, and sec a is inverse of cos. So cos a plus sin a cos a. Now I can take the LCM as sin a cos a. So in numerator I have 1 minus cos square a minus sin square a plus sin square a cos square a. This is equal to 1 minus sin I can take common, and I can write down this as cos square a plus sin square a and plus sin square a cos square a divided by sin a cos a. Now here we have 1, and sin square a plus cos square a is 1, so minus 1 plus sin square a cos square a, and this gets cancelled, divided by sin a cos a. Now one of the sin a and one of cos a will get cancelled from the numerator, so I'll get this as sin a cos Now we need to solve the right hand side too. Right hand side is 1 by tan A plus cot A. So this is equal to 1 by sin A by cos A plus cos A by sin A. Now we can take the LCM in the denominator. So 1 by, and the LCM is sin A cos A. Here I have sin square A plus cos square A. Now this is equal to inverse, so sin A cos A divided by sin square A plus cos square A. Now sin square A cos square A is equal to 1, so I can write down this as sin A cos A. So now we have got the right hand side as sin A cos A, and even the left hand side is sin A cos A. So I can write down here left hand side is equal to right hand side, hence proved. Tenth part, we have 1 plus tan square A divided by 1 plus cot square A is equal to 1 minus tan A divided by 1 minus cot A whole square is equal to tan square A. So let's solve these. So we have 1 plus tan square A can be written as sec square A, and 1 plus cot square A can be written as cosec square A. Then sec is inverse of cos and cosec is inverse of sin. So I can write down this as sin square A by cos square A. This is equal to tan square A. Now the second part, I can solve this as 1 minus tan, I'll convert into sin A by cos A and divided by 1 minus cos A by sin A and whole square. This is equal to cos A minus sin A. So this is for the numerator, and denominator cos A, as that is the LCM, and in the denominator LCM is sin A, and we have sin A minus cos A. This whole square, and this will be equal to cos A minus sin A divided by cos A and multiplied by sin A divided by sin A minus cos A. This whole square. This and this will get cancelled by minus 1. So I'm left with minus sin A by cos A whole square. So this I can write down as tan square A. So now all the three terms are tan square A is equal to tan square A is equal to tan square A. So hence proved. We have finished this exercise as well as this chapter, and now let's see which chapter we are going to start in the next video. So stay tuned and see you all.